Hello and welcome to Precalculus lesson number 5. In this lesson, we're going to learn about applications and modeling with quadratic equations. First, I want to quickly remind you about the three-step approach we're going to be taking with solving applications. Step 1 is, of course, to understand the problem, mainly understand what is given and what is wanted from you. Then we're going to move on to translating from English to mathematics. And finally, we're going to solve and make sure that we answer the question that was originally asked. First, we'll take a look at some geometric applications. Make sure that you are familiar with these simple formulas from plane geometry. The perimeter and the area given for the square, the rectangle, the circle, a right triangle, a general triangle, and a trapezoid. Note that in the special case of a circle, the perimeter gets a special name. We call it the circumference, which is basically the distance around the object. Also note that the circle is merely the part that you see in black here. We usually incorrectly refer to this as the area of the circle. It's actually the area of the disk enclosed within the circle. But we all know what we're talking about, so we usually let that error go ahead and slip. But just do understand, the circle is just a set of points that you see. I'm going around right now. And the inside part is a disk, not a circle. All right, so for our first problem, the area of a rectangular wall of a barn is 280 square feet. And we're given that the length is 8 feet longer than twice the width. Find the length and width of the wall of the barn. So quickly, let's look at which formula we're going to be applying. We're dealing with a rectangular object and we want the area, so length times width. One of the simplest formulas in mathematics. So in order to understand it, we'll try to use a little bit of a graphic to help us along. So we have a rectangular situation. Now your picture doesn't have to be perfect. Mine certainly never is. And we know that the length is 8 feet longer than twice its width. Now, whenever you have a scenario like this, one thing longer than or shorter than something else, usually it's easier if you start with what comes at the end, here with the width, right? So give that a name, then we'll name the other one based on the first name. So we have width and length. We don't know either, right? So we're going to just go ahead and call the width x, okay? So if the width is x, we know that the length is 8 feet longer than twice its width. Now, since what comes after longer than is twice its width, I'll start with that, with twice its width, so 2x, and I want 8 feet more than that, so I'll just go plus 8. So right now, we're just kind of like getting a picture of what's going on here, trying to understand the problem. We're still in step 1, right? So on the picture, it would look kind of like that, right? Now, we also know something about the area. So we know that the area is length times width. So I know that L times W equals A. And here, I'm pretty much ready, knowing I'm just going to put this information inside. The area is 280 square feet. So we're ready to go ahead and proceed and translate this into mathematics. We're in step 2 primarily. So here, notice that the length is going to be 2x plus 8 and the width is going to be x. So I'm going to get this expression times this expression. It doesn't matter which one of them I put first. I'll put the one with only one term first. It'll make it a little bit easier. So I'm just going to put W times L. It's the same as L times W, of course, because of the commutative property of multiplication. So I get x times 2x plus 8 equals 280. Now we just need to go ahead and solve this equation. As you'll see, it'll end up being a quadratic equation, and therefore that's why it's in this section, right? So we have 2x squared plus 8x, and I'm going to go ahead and move the 280 over, so it becomes minus 280 equals 0. Remember, change sides, change signs. Now I notice that I have a common factor of 2 in these three terms. Notice? So as I've mentioned in the previous video, if that does happen, you should go ahead and divide it off, because it's going to make life a lot easier with smaller numbers. So that's what we're going to do. We're going to divide both sides by 2, and of course on the left side it'll get split up like this, and we get that, right? So we get x squared plus 4x minus 140 equals 0, right? So now we're trying to factor this trinomial. So we're looking for, let's use the big cross, we're looking for two numbers whose product is negative 140 and whose sum is positive 4. So we'll go ahead and get help from our old friend prime factorization. We'll start with 140. We know 2 goes into it 70 times, and then 2 goes into 70 35 times, 5 goes into 35 7 times, and 7 goes into 7 1 time. Once we hit the 1, we're done. So here we have the prime factorization of 140 nicely laid out for us from smallest to largest prime factor, 2 times 2 times 5 times 7, okay? So I can make any combination here work, and let's see, for example, we have 2 times the rest, which is 70, or we have 4 times 35. But remember, we want the sum of the two numbers to be 4, right? So these numbers need to be pretty close to each other, not too far apart like 4 and 35. So we notice that we also have this pair and this pair that could work for us, 10 and 14. In fact, that's the pair we're going to use. So we're going to want a negative 10 and a positive 14, so that the sum becomes positive 4 and the product is still negative 140. We know that one of them has to be negative and the other positive, because we want the product to be a negative number, right? So there we have it. So we have x minus 10 times x plus 14 is equal to 0. Now we're just going to set each one of these factors equal to 0 by the zero factor property. So we get x minus 10 is 0, or x plus 14 equals 0. So either x is 10 or x is negative 14. Now let's recall what x is, right? Common sense check. X is the width of a rectangle. So clearly it can't be negative, right? You can't have a negative width. So therefore we're going to reject this one, and we're only going to accept the 10 value, right? So now if I just go back into this little table that I made, notice that I'm going to put 10 for x, so I know the length is just going to be 2 times 10, which is 20, plus 8, which is 28. And there we have it. So if we want to answer it properly, we'll say the length needs to be 28 feet and the width needs to be 10 feet, right? So we'll always put final answers with the proper units, okay? So we went through the 3 steps. We first understood the problem by, using a little table, a little diagram. Then we went ahead and translated from English to mathematics. Finally, we solved, okay? And that's all there is to it, just like before. Here's another problem. You should definitely see if you can figure it out on your own before you watch the rest of the video. All right, the length of each side of a square is 3 inches more than the length of each side of a smaller square. the sum of the areas of the squares is 485 square inches. Find the lengths of the sides of the two squares. All right, so again, we're going to try to use a little bit of a plot, a little drawing to help us along here. So we have a smaller square and a larger square, right? And we know that whatever the length of the smaller one is, the length of the larger one is going to be 3 inches more, the length of each side, right? So let's say that the length of each side of the smaller square is x. We don't know it, right? We just call it x. So obviously the length of each of the lengths, the length of each of the sides of the larger square is going to be x plus 3, right? Just based on what's given. Now, I know that whatever area this one has, we call it A1, and whatever area this one has, we'll call it A2. That's the amount of space you have inside, right? They're going to add up to 485, right? So how am I going to set that up? Well, easy, because I know that A1 plus A2 is equal to 485. So we just went from step 1, understanding, to step 2, where we're going to start to translate, right? Now, what is A1? Well, remember, the area of a square is very simple. Let's go back to our list of areas. See, for a square, the area is just the length of one side squared, right? It's a special kind of rectangle. So length times width, and the width is the same as the length, so length times length, that gives you what? Length squared. So for the area of the smaller triangle, we have x squared. For the area of the larger triangle, we have quantity x plus 3 squared. And all of that should add up to 485, right? So we have x squared. I can take care of x plus 3 squared very quickly right here. X plus 3, x plus 3. I don't have to memorize any formulas if I don't want to. So that's x squared plus 3x plus 3x plus 9. Those add up, so you get x squared plus 6x plus 9. If you know a formula such as quantity f plus l squared equals f squared plus 2fl plus l squared, by all means use it, that's fine. So we get x squared plus 6x plus 9 equals 485. So now we combine like terms and we move everything to one side. So 2x squared plus 6x plus 9, that totally simplifies the left side. I'll go ahead and move the 485 to the left side as well, becomes negative 485. So now we have 2x squared plus 6x. Now we're going to do 9 minus 485, and we get negative 476 equals 0. Now I could try to factor it as is, but again, I notice there's a common factor of 2, which I can divide off. So that's what we'll do. We'll divide both sides by 2. On the left side, that division splits up like that, so we end up with, remember the reason for that is of course that if you have a plus b plus c over d, that's going to be a over d plus b over d plus c over d, etc., right? So we get x squared plus 3x, so x squared plus 3x minus, now we're going to do 476 divided by 2, 238 equals 0. Okay, if you've done this already, great. If you haven't done it already, you should go and try to factor this using the same method that I showed you on the previous problem. Okay, I'm going to remove this stuff since we've already handled it. All right, so remember we take 238. We're looking for two numbers whose product is negative 238 and whose sum is positive 3. So again, the numbers need to be pretty close to each other so that their sums become 3, and one again has to be negative, one has to be positive. We know all that. So now we go ahead and factor 238. 2 goes into it, let's see, 119 times. Now 119 is not divisible by 2, is not divisible by 3 because 2 and 9 add up to 11. That's not divisible by 3. It's not divisible by 5. We can try 7. Let's try that again. 119 divided by 7. That works, okay? So 7 goes into it 17 times, and 17 is a prime number, so the only prime number that goes into it is 17, and that happens one time, okay? So it looks like we have our number right here. See, 14 and 17. They're 3 units within 3 units of each other, and their product is going to be 238. So which one should I make negative and which one should I make positive? Well, I need to make the 17 positive because it's the larger number, and I want the sum to be positive 3. So we put 14 here. So we have x minus 14 times x plus 17 equals 0. Now we apply the zero factor property, so it tells us either x minus 14 is 0 or x plus 17 is 0, right? Now, that gives me x equals 14 or x equals negative 17. Real life problems put restrictions on our answers, right? Like the x is the length of a square, can't be negative, right? So again, we reject that negative answer. We only accept the positive answer, so 14. So the length of each side of the smaller square is how much? 14 inches. And for the larger square, we're going to have 14 plus 3 or 17 inches, just like that. All right, so if you haven't handled this completely on your own yet, make sure you take the time to do that before you proceed. I know you're thinking that, okay, if I were to do that, my lectures and my video watching is going to take hours and hours. Yes, that may be true in the period of what I say, that gap filling is taking place. So in other words, there may be some gaps in your understanding of mathematics, and during the time where those gaps are getting filled by some of the detail that I show you and the work that you do, yes, in that period, they may take longer, but if you take the time to do that, eventually the gaps are going to get filled and the speed is going to increase, and you're going to be able to do these in a much, much more efficient way, right? So that's the great part about the whole thing. So hang in there and be patient. All right, in our next example, Julia wants to buy a rug for a room that is 18 feet wide by 26 feet long, as shown in this picture. And she wants to leave a uniform strip of floor around the rug. And she can only afford to buy 100 square feet of carpeting. What dimensions should the rug have? So basically, notice that we don't know what this uniform strip length is going to be, but we do know that whatever this gap is, it's going to be the same as that, the same as that, and the same as that. So in other words, if we were to label it, like say from here to here, if that's x, we know that this is also x, right? And So will this be, and so will that be, right? So all those will be the same length, which we don't know how much, but we call it x, right? Now, we also don't know the length and the width of the rug, right? But we do know that from here to here, in other words, the length of the room itself is 26, right? Now, the length of the rug is not going to be 26, but 26 take away 1x from this side and 1x from that side. Because notice, if this length is x, right? So is that length, and so is that length, right? So if we start with 26, which is the length of the room, and take away 2 of these x's, we should get the length of the rug, right? So the length of the rug is 26 minus 2x. In a similar way, we know that from here to here, meaning the width of the room is 18, and we know that if we take away 2 of these x's, right there and right there, we end up with this width, which is the width of the rug, right? So the width of the rug is going to be 18 minus 2x. Now, what we do know is that the area of the rug has to be 180, because that's all she can afford, right, to buy. So that's not money, that's in square feet, right? But that's the same kind of the reasoning. So we want the area of the rug to be 180. So that means we know the area of the rug is just going to be the length of the rug times the width of the rug, right? So we want that to be 180. Now we know the length of the rug is 26 minus 2x, and that the width of the rug is 18 minus 2x. And that product needs to be 180. So now it's just a matter of solving that quadratic equation. First, of course, we're going to go to standard form. So let's go ahead and do some distributing. I'll just work it horizontally rather than go to a table. We can just work it out like this. So we're going to distribute the 26. So 26 times 18, that's 468. 26 times negative 2x will give us minus 52x. Now we're going to distribute the negative 2x. Negative 2x times 18, that's negative 36x. And negative 2x times negative 2x, that'll give us positive 4x squared. And that should equal to 180. So we'll simplify, that's 4x squared. Now, we're going to combine the 52 and the 36. So they're both negative, so it's going to be minus 88x plus 468. Now we put it in descending order. And let's bring the 180 over, so it becomes minus 180. Change sides, change signs, right? That should equal to 0. So let's keep going. 4x squared minus 88x. Let's combine 468 and negative 180. That's positive 288. Now, it looks to me that 4 goes into all the terms, because all the terms end in 2 digits that are divisible by 4. So if we divide both sides by 4, we end up with the much nicer and simpler equation. X squared minus 22x plus, we're going to divide 288 by 472 equals 0. All right, so now we're going to factor this expression here. So we're looking for two numbers whose product is positive 72 and whose sum is negative 22. So we'll go ahead and factor 72. 2 gives us 36, 2 gives 18, 2 gives 9, 3 gives 3, and 3 gives 1. So here are some of our possibilities. We have 2 times 36, for instance, 4 times 18. That looks to be a winner, right? If we multiply those two, that's 4, and these 3 gives us 18. That looks to be a winner, and they're both going to be negative because we want the product to be positive, but the sum to be negative, right? The only way that can happen is if they're both negative. Notice that the sum is negative 22 and the product is positive 72. So we have x minus 18 times x minus 4 equals 0. So either x minus 18 is 0 or x minus 4 is 0. So this gives us x equals 18 or x equals 4. Now, if we take a look and realize that if x is 18, the width of the rug is going to be 18 minus 2 times 18, which is going to be 18 minus 36, which is negative 18. So that's impossible, right? So that we're going to reject. Too large. It's a different reason than previously. Previously, we were getting a negative value, but even a positive value may not be reasonable and feasible. So if we try x equals 4, notice that the length of the rug is going to be 26 minus 2 times 4, right? Which is 26 minus 8, which is 18. And the width of the rug is going to be 18 minus 2x, so 18 minus 2 times 4, that's 18 minus 8, which is 10. So there you have it. The dimensions of the rug are going to be 18 feet by 10 feet. Just like that, okay? So again, make sure that you can handle a problem like this on your own before we move on. All right, so we'll look at a couple of more geometry problems. For that, we're going to need some formulas for these three-dimensional figures, the sphere, the cylinder, cone, or pyramid. Now, we're not necessarily going to use all of them, but I just wanted to have these here for your reference. V is going to be the volume, so the amount of room you have inside. S is the amount of surface that you can touch, so the surface area, the total area on the surface of each of these objects. So particularly we're going to be needing this in the next problem. So notice the surface area is going to be the area of the circular bottom and the circular top. Each of those is a circle, so the area is pi r squared, or a disk if you want to say it more correctly. The area of these two disks is going to be pi r squared each, so 2 pi r squared. For the area of the cylindrical part, what we do is we basically take the perimeter of the base, which is the circumference of that circle, or 2 pi r, and multiply it by the height. That will give us the surface area of this portion other than the top and the bottom. Okay, so take a look at this and we're going to use it. So let me actually go ahead and bring it with us to the next problem. All right, so here we're looking at the surface area of a can of beans being 345 square centimeters. We know the height. We want to know the radius of the circular top. Okay, so let me bring that over. Okay, so this is the scenario we have. We have a can of beans. Of course, it's going to be in the form of a cylinder. We're given the surface area, so we're dealing with this formula, okay? And we're given the height, okay? And we want to find the radius of the circular top, which is the same as the circular bottom, right? So, all right, so we have 2 pi r squared. I always like to start with the formula and then plug in, because if you try to rush and do too many things at one time, you're much more likely to make a mistake. So just write down the formula at first. That's the surface area, right? Now we plug in what we know. We know that the height is 15 and the surface area is 345. So 2 pi r squared doesn't change because we don't have anything in that we know. And this one becomes 2 pi r times 15, right? So on the other side of the equation, we have 345. All right, so let's clean it up a little bit. So we have 2 pi r squared plus 2 times 15 is going to give us 30 pi r. And then let's go ahead and bring the 345 over. So minus 345 equals 0. Okay? So now we could sit here and start plugging things in, etc. Like that's going to be approximations for pi. That's just going to water down our results and make our actual result less accurate. So what we'll do is we'll go ahead and just pick our A, B, and C as is. So our A, notice we're in the right format. We're in the form of A times some quantity squared or some variable squared plus B times the same variable plus C equals 0. So we're in quadratic form, right? So let's go ahead and decide A, that's 2 pi, B, that's 30 pi, and C is negative 345. So R is going to be negative B plus or minus, remember, just write it down, don't plug it in. Square root of B squared minus 4AC over 2A. Now carefully substitute. So negative B, that's going to be negative 30 pi plus or minus square root of B squared, so quantity 30 pi squared minus 4 times A, which is 2 pi, times C, which is negative 345. And we're going to divide that by 2 times A, which is 2 pi. So 2 times 2 pi in the denominator. Now, the nice thing is, many of these modern calculators, you can just type that right in, okay? You don't have to do anything but carefully type it in. Let me show you. This is a great calculator, by the way, the HP Prime graphing calculator. It's available for free on almost every platform that I know of. So I don't see any reason to purchase one anymore. Again, HP Prime graphing calculator. There's a free version and there's a paid version. The free version is way more than we will ever need. Okay, so this is fine. All right, so let me show you how you would put something like this in. All right, I would actually start by just hitting the division sign. You see what happens? You get a fraction. Now, of course, I don't want that answer on the top, so I'm gonna go back, hit the top arrow, and then I just need to get my cursor into this position. So you may have to work with it a little bit. And then hit delete a few times or backspace. Now it's blank. So now we're just going to type in the numerator, okay? So I have negative 30 pi. Now, if you push the minus sign, these calculators are not going to be happy. You need to push this plus minus symbol here. So negative 30 pi, you need to locate pi on this calculator. It's the shift function of 3. So shift 3, or the second function of 3, okay? And then you don't need to put plus or minus, you just put one of them. So I'll start with plus, okay? I'll show you how you can easily handle the minus case in a minute. And then you're gonna hit shift x squared, that brings up the radical expression. Now I'm gonna type this exactly as I see it, okay? So I'm gonna start with parentheses, and I'm gonna go ahead and type 30 pi. Now I need to hit the arrow once to the right to get out of the parentheses. Now I'm gonna square, okay? Minus 4, I'm gonna open parentheses, type in the 2 pi. I'm gonna hit and exit that parentheses once. Make sure you don't hit it twice. If you do, now you're outside of the radical, okay? No problem, just hit it back once and go back in, okay? So we'll hit the parentheses again and we'll type negative 345. So make sure that we have typed it in correctly. Always, you know, anytime you're going from one screen to another, do yourself a favor, take like a few seconds to make sure you did the copying correctly. That could save you points on every test. Negative 30 pi plus square root of 30, the square root of 30 pi minus 4 times 2 pi times negative 345 over, now I'm going to go down. I just hit the down arrow. Now I'm going to put, I can put 2 times 2 pi, but let's face it, it's easier if I just put what? 4 pi, okay? Now I'm just going to hit enter. There it is. That's one of my possible solutions. So now you're going, oh gosh, I don't want to have to type all that again to do the minus case. Well, you don't have to. Guess what? Just double click that. Just highlight it and double click it. It copies it, okay? Now just click here, right after the plus, backspace, put a minus instead. So now you're going to calculate the minus case, okay? We notice that the minus case gives us a negative radius, which is impossible. You can't have a negative length, right? So the only possible answer is this one that we're going to take, and if we round it to the nearest hundredths, it'll be 3.04. That's what we will use. So we'll say approximately 3.04 centimeters, okay? That's the radius of either the base or the top, okay? That's how we do that. All right, so get comfortable with doing that kind of plugging in for your calculators, because it can save you a lot of hassle. All right. So if you want to, present it nicely, usually in my math lab, for example, you'll just be putting it like this. You'll only be typing in the 3.04 because they'll be providing the centimeters. So don't type in the centimeters inside the box, because that's going to be centimeters times centimeters or square centimeters. It's going to give you an error. And here they will give you directions, like they'll say don't round till the final answer, which is a great direction, because that means you're only rounding once, therefore you're reducing the error. And then they'll tell you what to round to, like to the nearest hundredths as needed, okay? So I wanted to show you this because this is what you're going to encounter when you do problems on my math lab. Okay, let's switch things up a little bit and look at another kind of problem that usually runs into quadratic situations, and that is projectile problems. Okay, here we have a projectile that's launched from the ground level with an initial velocity of v0, that's how you would read that, v0 feet per second, neglecting air resistance. Its height in in feet, t seconds after launch, after launch is given by s equals negative 16t squared plus v0t. Find the time that the projectile will do two things. First of all, reach a height of 80 feet and then return to the ground if the initial velocity v0 is 96 feet per second. Okay, so we know that negative 16 t squared plus v0t is going to equal to s, right? Now I'm going to write it like this just because it'll be a little bit easier to work with in this format. Now it's telling me that the initial velocity is 96, so v0, so I'm going to substitute that. Negative 16 t squared plus 96t. This is for part A. Now for part A, I want to know when I reach a height of 80. The height is presented by s, right? So I'm going to set that equal to 80. Now let's move everything to one side. Negative 16 t squared plus 96t minus 80 equals 0. I move the 80 to the left side. Now, I do believe all of these are divisible by 16, in fact, okay? So 96 is 16 times 6, and 80 is 16 times 5. And as you work with numbers a lot, and I guess you have no life, then you tend to remember these things. All right, so let's go ahead and divide both sides and get rid of the 16, but better yet, we'll divide by negative 16 to make the lead term positive as well. So let's do that. So let's divide both sides by negative 16. Now, if you don't see that, is it the end of the world? Is it impossible for you to get the right answer? No. You'll be dealing with some really large numbers, and you can go ahead and plug them into the quadratic formula and it'll work out. But I think it's always better to be efficient in this way, because that just makes you a better math student. So we get t squared minus 6t, and then negative by negative here is going to give us positive, so plus 5 equals 0. Now that becomes a simple problem. We're looking for two numbers whose product is positive 5 and whose sum is negative 6, right? So what do we think those numbers are? Well, think about it. The only way that can happen is with negative 5 and negative 1, right? Because their product is positive 5 and their sum is negative 6. So we have t minus 5 times t minus 1 equals 0, right? So either t minus 5 is 0 or t minus 1 is 0. So we either get t equals 5 or we get t equals 1. Now, how does that work? Does that make sense? Well, think about it. Here's the ground, right? You're shooting a projectile up. What's going to happen? Well, it's not going to go on up forever, is it? Unless it has such a high initial velocity called the escape velocity, which even lets it go push right through the Earth's atmosphere and enter into space, right? But in normal circumstances, you push, you shoot a projectile up, it's going to go up for a certain period of time, and then Earth's gravity is going to do a number on it, and what's going to happen? It's going to come to a stop, and then it's going to come back down, right? So it's going to go up, and then it's going to turn around and come back down, right? So up, then down. So it's going to reach a height of 80. In fact, it's going to reach every height other than its max height, right? Twice. Once on the way up and once on the way down. There's only one height that it's going to hit only once, and that's its maximum height, right? So therefore, this makes sense that you're going to hit a height. Let's say this is the height 80, right? Depicted right here. Let's say that's 80. So it's going to hit it once on the way going up, and once again on the way going down, right? So there you are. That's how long it'll take, the time that the projectile will take to reach 80 feet. Once after 1 second, and again after 5 seconds. Now, for the second part, B, we want to know how long it'll take to return to the ground. In other words, remember the ground level is height 0 feet, right? So if you figured out what needs to be done, go ahead and take care of it. If not, you can keep watching, and if you do, make sure you do it all over again on your own. Okay, so we want negative 16 t squared plus, this time I'm just going to plug in the 96 t to reach a height of 0. That's what we're doing. The only difference between these two parts is the value that you're going to use for s. Of course, the height 0 is what represents s for part B. So now we just need to solve this simple equation. So now I notice that I can divide off the negative 16 again. So we end up with t squared minus 6t is equal to 0. So factor out a t times t minus 6 equals 0. Apply the zero factor property, so either t is 0 or t minus 6 is 0, which gives me t equals 6. So there are 2 times that for the second part as well, which makes sense. Obviously, it's going to hit level 0 before it takes off, and once again when it returns. So t equals 0 is right at the moment of takeoff, right? And t equals 6 is when it comes back down to the ground level. So it's going to reach the ground level after 6 seconds. All right, so that is how you would handle a problem like that. Again, these are in some ways easier than those geometric problems because usually you know the formula and it's a matter of plugging in and solving, okay? So don't let the look of these scare you. All right, for our last problem of the day, and this is going to be a relatively short video, so hopefully it'll make up for our last video, which was nearly 2 hours. So in 1994, the sports league, by the way, it goes under the category of modeling, quadratic modeling, which is similar to linear modeling, basically an equation which happens to be quadratic and which represents a real life situation, which has been modeled by observations and then fitting the observations to certain models, okay? Now, in 1994, the sports league introduced a salary cap that limits the amount of money spent on players' salaries. The quadratic model y equals 0.2313x squared plus 2.600x plus 35.17 approximates this cap in millions of dollars for the years 1996 to 2006, where x equals 0 represents 1996, x equals 1 represents 1997, and so on. In other words, a better way of saying that is x is the number of years since 1996. Okay? So x equals 2, for example, would represent 98. X equals 10 would represent what? 1996 plus 10, which would be 2006, etc. So complete parts A and B below. Approximate the sports league salary cap in 2004. All right, so basically we first need to figure out what the value of x is going to be for 2004, right? Now, to do that is very simple because remember, x is the number of years since 1996. So x here is going to be 2004 minus 1996, just like that, very simple. So, and that will be 8. And now all we have to do is plug in. So we want to know the salary cap. We just have to go y equals 0.2313 times 8 squared plus 2.6, we don't need those zeros, they don't count, times 8 plus 35.17, okay? So, My pen is acting a little funny. Here we go. So let's go ahead and just compute that, okay? So our good old trusted HP, 0.23, oops, 313 times 8 squared, which is 64. Let me just type in 64 since I know that. Plus 2.6 times 8 plus 35.17. Okay, again, you're transferring from one screen to another. Double check. 0.2313 times 64 plus 2.6 times 8 plus 35.17. We hit enter, so we get 70.77. With money, we usually don't go more than a couple of decimal places. So approximately $70.77 million. All right. For part B, we want to know, according to the model, in what year did the salary cap reach $90 million? Again, you have to be very clear about what X and Y stand for, then these become a piece of cake, right? Now, X is the number of years since 1996, and Y represents the salary cap in millions, right? So what they're giving us here is Y, the salary cap. So we have 90 equals 0.2313 x squared plus 2.6x plus 35.17. Let's go ahead and move everything to the right side. So we get 0 equals 0.2313 x squared plus 2.6x. Now we're going to have plus 35.17 minus 90. So let me take care of that. 35.17 minus 90. That gives me negative 54.83. So by the quadratic formula, let's see what A, B, and C are. So A is 0.2313, B is 2.6, and C is negative 54.83. So X is going to be negative b plus or minus square root of b squared minus 4ac over 2a. Always write the general formula down, then substitute. So negative b is negative 2.6 plus or minus square root of b squared, so 2.6 squared minus 4 times 0.2313, that's A, times C, which is negative 54.83, all of that over 2 times A, which is 0.2313. So now we're just going to go to our trusted friend here. Remember how we enter that? I start with just hitting the fraction line, and then I'm going to go there and replace the A and S with the numerator. So negative, oh, don't put that negative, put this one, negative 2.6. I'll start with doing the plus case, and then I need shift x squared. So 2.6 squared, just type it exactly as you see it, minus 4, I'll open parentheses and put in 0.2313. I'll exit the parentheses once, not twice, because you don't want to get out of the radical. times negative 54, don't forget, use that negative sign, 54.83. And now we go downstairs and we put in 2 times, I can just use parentheses, 0.2313. Now we pray that we've put everything in correctly, and we double check as well. All right, so negative 2.6 plus square root of 2.6 squared minus 4 times 0.2313 times negative 54.83 over 2 times 0.23 times 13. All right, I'm trying to practice what I preach here because it's really important. You don't want to miss points for no reason. So we get approximately 10.8, say, right? 10.8. So let's go ahead and do the minus case. That gives us negative 22.01. That doesn't make sense for a number of years since a given year, so we can ignore that one. Now, the instructions on this one say round down to the nearest year. So this will round down again to the nearest year to 10. So now, remember what this stands for. This stands for the number of years since 1996. So what year did this actually happen when the salary went up to 90 million? You would just go, the salary cap, I should say. So that would be 1996 plus 10, which would be 2006, like that, okay? So that's how you would handle a problem like this. Again, these modeling problems are actually easier than those geometric ones because the model is given. You don't have to come up with the equation, right? Okay, so that should pretty much take care of this lecture, and you take care of yourself. We'll see you at the next one.